He said it's...
This is that blonde girl.
Brandon! Good morning, class. It's not the morning. Good afternoon, class. So, your test will be in lesson 106. Mr. Dasky is not here, so I am your sub today.
What's your name?
My name is Miss Genesis.
What's your last name? What's your
All right. Well, it's professional day. She's a teacher.
What did you just say?
Well, I couldn't decide between math teacher or sports talk guy.
Oh.
So I decided, because I was like, if I weren't a teacher and I could pick anything, and I didn't care what God wanted, what would I be? I'd love to talk about sports and be paid to do it. Like, that would just be an awesome job. It doesn't accomplish anything for the cause of Christ, and it's not what He's called me to. But as much as I talk about sports, can you imagine getting paid to do that? Awesome. Okay. So anyway, so I go back and forth between ESPN and Grace Christian.
Do you have voice changes?
Your voice, yeah.
Yeah, just do voice changes every time it flips.
Voice changes every time. I don't know. My voice is what it would be on TV too. This is why I don't have a contract. That I haven't applied, but I wouldn't get it. All right, your homework. As Miss Genesis, mentioned, yes, and I put this in the description of the last two videos because I realized my mistake. This is lesson 105 right now. This is not the test. The test is tomorrow. So the test is lesson 106. That only concerns Gavin, Brecken, and future students watching. Nobody in here cares, but you care because you want one more review before the test. You want to take a look at your homework. All of you want to look at your homework, page 219. You did numbers 2 through 28, the even, and we will review everything as much as time allows. Today we move quickly, we review everything, we move slowly. Well, good luck tomorrow. All right, so page 219 to 220, 2 to 28, the even numbered problems. Math is full of problems. We solve problems here. We have a psycho in the class, somebody like that to help us with our problems, and that's helpful.
Psychologist.
We have a psychologist here in the class to help us today. We also have the paparazzi, a photographer. We have a cowgirl that makes me think of, what was her name again? Jessie from Toy Story. Thank you. This is my good side. We have a cow, a farmer, a dairy farm owner. And then we have a soccer player,
He's a
football, and we have a student with kitty cats socks. So anyway, it's been great this week for Spirit Week. I didn't mention yesterday it was Red, White, and Blue Day in case you couldn't tell from the red, white, and blue. But anyway, number 2 on page 219. You were supposed to find the midpoint. And you know I'm going to call on you, Psycho. What is the midpoint of number 2?
The midpoint is 7 halves, 5 in parentheses. What? No.
Formula.
What is it, Brandon?
15 halves, 21 halves.
Oh,
How did I get
I don't know how I got that.
Audrey.
7 halves, 5?
7 halves, 5 halves. Okay, so remember, you're going to add the x's together and divide by 2. You're going to add the y's together and divide by 2. Not subtract. If you subtract, you get 15 halves.
Oh.
If you subtract, you get 21 halves. Add to get 7, then divide by 2, 7 halves, or 3.5, or 3.5, any of those works. And you added, Abby, here to get the 5, but forgot to divide it by 2. So 5 halves, or 2.5, or 2.5, any of those would work for the midpoint on number 2. I already got one of those answers. I just called on the wrong 2 people. Like number 4, yes. You're supposed to find the slope, and then also state if it's positive, negative, 0, or undefined. Anyway, whatever. Psycho, what did you get for the...
I don't respond to that.
Well, unfortunately, you have to right now, but I'll stop calling it. Abby is our psycho, in case you couldn't tell. Abby, what did you get for the slope?
For number 4?
For number 4.
15 over 14.
Oh, Brandon.
14 over 15.
14 over 15. Remember, it's the y's over the x's. Y's over the x's. All right, this next one, I'm not going to call her a psycho first because I think it's messing with her answers somehow, retroactively. So 14 over 15. So obviously, class, is the slope positive, negative, 0, or undefined?
Positive.
It's positive. If it were negative, you would see a negative sign. If it were 0, there would be a 0 in the numerator.
Oh.
0 numerator, 0 divided by anything is 0. You can try that on your calculator. 0 denominator, remember, would be the undefined. Number 6, third tries the charm. Oh, you're just graphing. Never mind. So when you graphed, you should have plotted a point at 3, -1. Should have risen 2, run backward 3, and drawn a line that looked like that. How many have a line like that on number 6? Number 8, you're supposed to convert to slope-intercept form and graph. What was it when we converted to slope-intercept form, Abby?
Y equals 5x minus 2.
Good, and so when we graphed, we should have put our y-intercept at -2, risen 5, run forward just the 1, because it's 5 over 1, and when we draw the line, we should have gotten a graph that looks like that. How many have that for number 8? Question. Didn't get the equation or didn't get the graph, or both?
Cows can't graph.
Use their mouth. They can obviously use paintbrushes because they paint things all the time on the Chick-fil-A signs.
Yes,
All right.
I just didn't run.
Just didn't run. You just rose 5. And it's like when you were in my PE class, I just didn't run. I'm just kidding. She was good at PE. All right. Number 10. Find the slope-intercept form of a line given the information there. How do we find the equation of a line if we know 2 points that are in the line? And I think we're to Michael by now. Michael?
Slope-intercept form?
Yeah, how do we get the slope-intercept form here?
You find the slope.
Start with defining the slope. We're using the y2 minus 1 over x2 minus x1. What is the slope here?
Let me figure it out because I think I got my answer wrong.
Oh, for shame.
So it's 6 over -1.
So in other words,
-1, 6 ones.
-6. Let's just go with -6. That's our slope. All right, once we found the slope, then what?
You got to do the y equals xm plus b.
mx plus b,
Yeah.
because we want the coefficient before the x to be the slope, and so we plug in some numbers here.
-6
That's this one right here.
equals -6
That's this one right here.
times 6
That's that one right there.
plus b.
Excellent. And it looks like all 6s if you don't write neatly, and then you look very confused. But we multiply to get.
-36.
We add it to the other side as a,
Positive 36.
and it gives us our y-intercept of
30.
right. And so we end up with what equation here, Michael?
Y equals -6x plus 30.
And there we go. How many have that equation for number 10? Okay, questions. Questions on finding the equation of a line. All right. Number 12, excuse me. Determine if the lines are parallel, perpendicular, or neither. In order to figure it out, we've got to know the, what, Genesis? Well, that's true. Know the slope-intercept form so that we'll know the slopes, right? To tell if lines are parallel, we got to know slopes, perpendicular slopes, so forth. But we need to get them into slope-intercept form. So x minus 10y equals -4. To get that into slope-intercept form, 2 steps.
Assume x over negative. Divide everything by negative.
So what's the slope of my first line?
Y equals x over 10.
Well, I've got negative divided by negative, though. By x over 10, or we could say a 10th x
Plus 2/5.
plus 2/5. The only number I care about is the slope, and it's
The 2/5.
Ooh. the 1/10. Remember, the coefficient of the x is that slope. That number in front is that slope. So the 1/10 is the slope of my given line. Then we go to the next line. 2x minus 5y equals 4. Walk me through that one.
You send the 2x over.
That's a 2.
And then you divide everything by
All right, again, the only thing I care about is the slope. What's the slope of that line?
y equals 2/5 x plus -4.
All right, so again, the slope is 2/5. All right, is that the same thing? No, 2/10 would be the same as 1/5. 2/5 is not the same as 1/10. They're also obviously not negative reciprocals, so these lines are neither parallel nor perpendicular. Number 14, you're supposed to find the equation of a line that's perpendicular to x or y negative 3x negative 9. And perpendicular means what, Maddie? So if this is my given line, then that means that the slope of my line has to be positive 1/3. Negative 3 over 1, positive 1 over 3, that's my slope. And they want it, the equation of the line that goes through negative 7, 6. So we're going to go through this point with this slope. Walk me through.
Right slope intercept y equals x plus b. And then we plug in 6 equals 1/3 times negative 7 plus b.
I do wish the 6 had been the x, because I could have taken 1/3 of 6. I can't take 1/3 of negative 7.
And then get 6 equals negative 7 over 3 plus b. And then you multiply everything by 3.
Yeah, I think that's a good move here. Multiply everything by the 3. What did that give you when you did that?
18 equals negative 7 plus 3b.
Good. Don't forget to multiply the b by the 3 as well. So we do bring the 7 over as a,
Positive
to get,
25.
but it's not equal to b, it's 3b, so that b is equal to 25/3. So I know my slope, I now know my y-intercept. What's my line perpendicular to that one through that point?
Y equals 3 plus 25 over 3.
Like kind of a psycho fraction bar going on there. All right, how many had that equation for number 14? How many took the time to put it into the standard form and you ended up with an x negative 3y is equal to negative 25? I think that would be right. Yes. Had that equation? Anyone take the time to do that? Questions? I'm getting some puzzled looks. Checking your work.
Oh, I miscopied as 1/2
Oh, okay.
the slope.
All right. Questions, comments? All right. Into some more recent material. Now, all of that goes back a little ways, and then we kind of changed gears as we talked about variation. Number 16, do we have direct or inverse variation going on here in number 16, Kendall?
Inverse.
If it's inverse, what's going to be true?
You can divide them.
Inverse means they always multiply to get the same thing. You'll consist x, y equals k, right? So you're going to always multiply to get the same thing. Do we get the same thing every time we multiply in 16? Then it's not inverse variation, is it? It must be direct. Direct variation means you multiply x by something and it always spits out y. What do you multiply x by to get y?
-3.
Good. So then your constant here must be negative 3, and we would say our equation is not y equals kx, but y equals negative 3x. You multiply the x by negative 3, it gives you the y. Does that make sense now? All right. How many had that for number 16? Questions on that? Do we want me to make up another table of values to give you practice with something like that? Okay. Number 18 says let f and g be inversely related such that f is 13 and g is 24. Find f when g is 12. What equation should I write to show this inverse variation? Abby?
FG equals K.
Fg equals k. And so when we plug in the f and the g that they give us, what do you get for your constant?
You get 312.
Yes, that would be correct. All right, so fg equals 312, then we multiply the 13 and 24. And then it says find f if g is 12. So if g is 12, we already know the k is 312. What must the f equal? And for this you got?
26.
26 is correct. How many had this? For number 18. All right, questions on this problem?
I just did f equals k.
Oh, okay, so instead of, so you doomed yourself because instead of the proper form, you went with the direct form. So gotta keep them straight. Y equals kx is direct. The product constant is inverse. All right. Let's turn the page. Number 20. Does this set of values represent a function? Yay or nay? What sayest thou, photographer? It does indicate a function. We have no repeated x values, so should be good to go. Number 22, is that a graph of a function or no? Audrey?
No.
No, why not?
Because when you draw the line, it goes through twice.
If you drew a vertical line, it would cut through at 2 points. That's no good. So not a function. Number 24, is that a function, yay or nay, Michael?
Yes.
Yes, it is. Now, if you're going too quickly and you see, well, y squared, no, but hold on now. We've got a proportion here, don't we? We've got an xy cubed plus 3x all over. I'm not sure why they said yx. It should be xy. Is equal to y squared positive x negative 10. If you put it over 1 and cross multiply, it ends up working out pretty nicely for us. We've got our, of course, our xy cubed plus 3x stays as is when you multiply the extremes, but when you distribute in the means, you get that xy cubed plus x squared y minus 10xy, and the xy cubes drop out. You'll notice there's no more y squares left, are there? So we're never going to have to take the square root, but what would I have to do to solve for y? Anyone? Factor it out. I'm going to have to factor out the y and say x squared minus 10x equal to the 3x. And if I were to divide away the x squared negative 10x, that's what would equal y at that point. But there's no positive negative. So therefore, it is representative of a function. Number 26. What's the domain of that function, Audrey?
All real numbers.
All real numbers. You can plug anything you want into absolute value. What's the range of the function, Genesis? Good. That absolute value can only spit out negatives. That means negative infinity to 0. But then we take this range and we subtract 2. So it's going to go negative infinity up to the negative 2. Number 28. What's the domain here, Kendall?
All real numbers except negative 1.
Good. You can't have a denominator equal to 0, and a negative 1 for your x would give you a 0. Can't do it. All real numbers except negative 1 for your domain. What about the range, Maddie? All real numbers except positive 1. Again, that comes from the ratio of the leading coefficients. It's a 1x in the top and a 1x plus 1 in the bottom. The ratio of 1 to 1 is 1. 1 is the excluded value, if you will, from the range. All real numbers but positive 1. Questions on these? Was anyone perfect on the homework? Just out of curiosity. Anyone just missed 1 or 2? Just missed 1 or 2 on the homework. Missed just 3 or 4. Okay, so didn't do bad. Questions on any of those? All right, flip back to page 219. So just turn back the page. You did the evens for homework. I want you to do the odds now. Now that we've had a chance to go over them, so even if maybe you made some mistakes, well, all of us made at least one mistake in the homework, as we go through and do the odd numbered problems now. Let's see if we can correct those mistakes that we made. And make sure that tomorrow we make no mistakes. Get some perfect tests tomorrow. Mr. McDonald's voice is quite loud. What? He's touring? I don't know. I felt it like being nosy and just poking my head around the corner and seeing what's up. If they're going to have a party, maybe there's food. I'll let you know. Pretty spicy. He's touring. No waffles.
Can I go take the pictures?
No. You can sit down and do 1 through 27 the odd. I'm done. This section gives a really good overview of what's going to be on the on the test tomorrow. Just one test rate, not two. Like a little fishy in an aquarium.
Look
at the one with the striped fins. What?
If they peek, I'm making a face.
Can I take a picture?
They're not coming yet.
They're gonna
Except Brandon.
Who wants the points?
Tell you what, if you get 100 on your test tomorrow, let's take a picture of it. How about that? Show it to your mom.
I can bring the camera now.
He's gonna sell that.
I'll take a picture of it and send it to your mom.
He'll sell that picture on eBay.
I would. People might actually buy it. It's eBay, come on now.
I've got a lot of things listed on eBay that haven't sold yet.
Some people
It's just
sell
you.
hot sauces from Taco Bell on eBay.
Yeah, and people actually buy them.
Why not go to Taco Bell and get them for free?
I don't know.
You don't have to pay shipping.
They're not that.
Clearly. Maybe if I included a free pack of taco sauce from Taco Bell with every textbook purchased on eBay, my sales would go up.
Yes.
You should also like throw in a
That's the one.
10 chicken nuggets from McDonald's.
Holy
They would still be good by the time they got there too, or at least as good as they ever were.
I heard the rumor that McDonald's burgers never go old.
They don't.
They
They
don't
don't.
know. Did you get that story about the dude that found his coat in his closet after 20 years and he had a McDonald's burger in it and it still looked the same?
I don't doubt it.
It's McDonald's, come on.
And the foil that they wrap this stuff in must be really preserving.
They don't wrap it in
Paper.
Foil is
Wax paper, you mean?
Yeah.
Genetically modified foods, what? But if you get the Egg McMuffin, that's a real egg. It's the only thing you'll get a real egg with.
It's a weird looking egg.
It is, but it's real egg. Like,
I used to think it was like brains or something.
I don't like McDonald's things. I don't like breakfast.
What?
anyway, that's not helping you get ready for your test tomorrow, though.
I mean, eat a good breakfast, pass the test.
That's true. Go to Waffle House then.
Yeah.
You'll also be helping your immune system.
Exactly.
It's like Southern Hibachi.
Southern Hibachi.
Excuse me, what?
Except they don't clatter the knives around as much.
No.
Usually. How many have been to Hibachi? I love Hibachi. If you have a good chef. Entertaining, fun, that kind of thing. Cooks the food all the way through. Because if he doesn't, he keeps things interesting during the meal, and the meal keeps things interesting after the meal. almost finished. So a couple minutes to finish up, but if you finished early, once you're finished with that classwork assignment, got 4 problems for you on the board. I guess someone tripped and fell.
Can we take pictures?
Why?
If it was somebody you knew,
I put it in the yearbook.
unless it was your little
So
sister.
you put him in the yearbook.
Little kid by himself.
There's plenty of those videos on YouTube and America's Funniest Home Videos. So.
Maybe we could get rich.
You know that's like out of business now, right?
You don't gotta know.
Could you like write the equation for range? The range? The D?
You don't know the
Distance?
equations?
You mean the distance formula?
Yeah, that.
Range.
You don't know the distance?
Well, look up the distance formula.
You don't know the distance for shit.
Or it's a shoe.
It's like a chalkboard.
We can go with that too. Take just about another minute or so to be finishing. Are you all finished with the extra problem as well? Excellent.
I haven't gotten the equation.
Look it up.
Where can I
Or you could ask me.
The section. No, don't ask
That's her.
Ask the psycho.
I'm here for you to talk to me and tell me all your problems.
Tell you about the question.
ask me for
I'd
help?
love to know everyone's problem. I mean, I love to help people. That's what I do, help people. Yeah. And tell them more problems they didn't know they had. Your battery died, didn't it?
No, it isn't.
Yes.
It's all
Doesn't know.
All
2 bars. Sorry.
Well, hopefully you'll be able to focus better than this on the test tomorrow. Well, let's go and take a look at the classwork that you did. Number 1, what was this midpoint? Abby.
11:5.
Boom! There we go. 11.5. Yeah, absolutely. All right. How many got 11.5?
I got 4.
Questions? All right. Number 3. What was the slope of the line, first of all, Kendall? Number 3. Yeah.
14 over 0.
Which would be undefined. Good. Over 0 is undefined. 0 over something is 0. Something over 0 is undefined. If you're ever curious, plug into the calculator. If it says error, that's undefined. If it says 0, that 0. All right, number 5, you were supposed to graph. You should have plotted the point 2, 1 in the first quadrant. Should have from there risen 1, 2, 3 more and run 4, 1, 2, 3, 4 more, and connect the dots with a line that looks something like that. For number 7, what did you get when you put it into slope-intercept form, Michael?
Let me grab my graph paper.
Number 7, what did you get for your equation?
Hold on, I don't know where I put my word. Oh, I didn't put it in self-intercept form, I just grabbed it. Y equals negative 2x minus 9.
Good. And so we would have had to come all the way down here to negative 9 on our y axis. From there, risen 2, run backward 1. I don't know why that word's giving me trouble today. And it should have had a line that looks something like this for number 7. Do we have something like this for 7? All right, any questions on those first few? Let's go ahead then to number 9, finding slope-intercept form of a line. Given that the slope is 4 and it goes through the point negative 13, 2. Walk me through the process here, Genesis.
You do the y equals 1x plus b.
Okay.
You do 2 equals negative 4 times negative 13 plus b to get 2 equals 52 plus b, and you bring the 52 over as a negative to get negative 50 equals b. So then your equation is y equals negative 4 equals 50.
Perfect. How many have the same thing as Genesis? Aren't you glad they didn't ask you to graph that one? Well, actually, if they'd asked you to graph it, you would have just gone off of the original stuff they gave you, right? Negative 13 is annoying, but negative 13, 2, right? Negative 13 this way, and then up 2, put you in the second quadrant. Then from there, rise 4, run backward 1. That graph wouldn't have been so bad, but trying to graph a y-intercept to negative 50 would just be obnoxious. Number 11, are those lines parallel, perpendicular, or neither? What did you come up with, Audrey? Why? And what is the slope of both? 4 over 1, or just 4. How many had parallel for 11? Ooh, questions on 11.
I was just working on it.
Okay. Number 13, we needed the equation of a line that's parallel to y equals x plus 3 through the point negative 7, 6. Walk me through this one, Brandon.
The slope of that line was 1, so I used the point negative 6 to 6 to earn it.
You mean negative 7, 6?
Yeah, that's right. Y equals x plus b. And I put in 6 equals 1 times negative 7 plus b. And then I multiply and moved over to 13 equals b. And then I plug that into the equation. And we'll make the new equation y equals x plus 13.
There we go. And there's the parallel through negative 7, 6. How many had that for 13? Questions on 13?
I just didn't get there yet.
Okay. Number 15, would we have direct or inverse variation here? Direct or inverse? What does it appear to be, Maddie? Well, if it's inverse variation, you're going to be able to multiply the two numbers and get the same thing. But if I multiply the two numbers, I'm getting 0, 3/4, 12, 27, 40, I'm getting all kinds of different numbers. So it can't be inverse variation, it's got to be direct. All right, what would I be multiplying by each time, though, to get y? That would be if you were getting x. We're assuming y is the independent, or the dependent variable. So we'd multiply not by 4/3, but by 3/4, right? 0 times 3/4 is 0. 1 times 3/4 is 3/4. 3/4 of 4 is 3. Skip the next one, it's annoying. 3/4 of 8 is 6, right? So use the easy ones to see, okay, that means y equals 3/4 x. I suppose if you said x equals 4/3 y, I could give it to you, but it's not normal to put the x equals. It's normal to have the y as the dependent, which is why we think of y as a function of x. But I would technically take either of these, unless it specifically said y is the dv. How many had one of those for this one? All right, questions? Number 17 says, let r and t be inversely related, such that r is 12 and t is 36. Find r when t is 18. And what did we have for our formula equation-y thing here? Michael.
12 times 36 equals K.
All right, so RT equals K. So plug in the 12 and the 36 to get a K value of?
432.
All right, so therefore RT equals 432 is your equation then. T is 18, R must be?
24.
24. So RT equals 432, and so we end up with an answer of R. It was R equals, yes. R equals 24. How many had that for number 17? Questions? All right, remember, inversely related, constant product, directly related. The one is something times the other. Number 19, yay or nay on function, class?
Nay.
No. Where do we see a problem here, Audrey?
The fives.
And?
Twos.
The 2's and the 5's both present a problem, don't they? We have two different y's for 2, two different y's for 5. Definitely not a function. Number 21, what's the verdict, class?
Yes.
Yes, because it passes the vertical line test. Number 23, is that a function, class?
No.
No. I would do a double switch here to get the x squared minus the 16 equals the positive y squared. But then you got to take the square root of the y squared to get y equals positive, negative, and right there. Not a function. Number 25, what is the domain of the function going to be, Maddie? What about the range of the function there on 25? Abby?
All real numbers.
Also all real numbers. There's no limiting factors there. No limiting traits. We don't have a constant function or an even root or a what are the other ones? Absolute value or a quadratic or a fraction or anything like that. So it's just all real numbers for both. What about 27? What's the domain on this one, Brandon?
Negative infinity to 30.
You can put as big as a 30 in there, but if you put bigger, it would give you a negative radicand. So negative infinity up to the 30 is your domain. What about the range of values you'll get out of the function? Kendall?
30 to infinity.
Well, what kind of values does the radical as a whole put out?
Positive.
Positives only, right? Which means 0 to infinity. Are we adding anything to the whole radical? No. So do you see here, the plus 30 doesn't come after the radical where you get this positive plus 30 more. It's just the radical is positive. So again, if you had plugged in a 30 in there, that gives you a 0. And anything smaller than 30 you plug in gets you a bigger value coming off. So 0 to infinity should have been our range. Does that make sense? All right. Questions on those? Questions on those? All right. Make sure you're good to go with those rules. Before we take a look at this, a lot of terminology in this chapter. Some formulas we got to know, some facts we got to know. For instance, we need to know that this number line, class, is called the y-axis. We know that this number line is called the x-axis. Of course, we put arrowheads on the ends. We put x and y labels on the positive ends. And 4 sections here called quadrants. And this is quadrant 3. This is quadrant. This is quadrant. And this is quadrant 2. Okay, so 1, 2, 3, 4. This whole thing is referred to as the Cartesian plane or coordinate plane. This point right here where the axes intersect. 0, 0. This point here has some x value. It also has some y value. What do we call the x value of this point? The abscissa. What do we call the y value of the point?
Ordinate.
The ordinate. And when I put them together in an ordered pair, I have what's called the coordinates. If I were to draw a straight line, this line has a point where it cuts the x-axis. Also has a point where it cuts the y-axis. In general, these points are called intercepts. By the way, a parabola is going to have a couple of intercepts here, right? A couple of x-intercepts and a y-intercept. This just has a single x and a single y-intercept there. Let's see, we said that an equation that gives you a straight line is called a linear equation. And you'll know you have a linear equation because x and y are both to the first power, right? Whereas the parabola, remember, comes because the x is squared. Okay, so a squared x gives you that parabola. First powers on everything, gives you the straight line, the linear equation. Trying to think other terms we had. Point in the middle of a line.
Or
Midpoint. Slant of a line.
slope.
Slope. We said a line that slants like this. This is negative. This is positive. This is zero. Full timeout. Anyway. Let's see other things we needed to review. Formulas. What's the distance formula, Michael?
The square root of x2 minus x1 squared plus the quantity of y2 minus y1 squared.
Good. What's the slope formula, Audrey?
Negative. Well, y2 minus 1 over x2 minus x1.
Good. And remember, this one, the order very much matters. Whichever y you pick to be y2, you start with this one or you start with that one. Let's just say you start with this one. You better start with this as your x2. Here it doesn't matter so much, remember, because of the square kind of negates that effect. Very much matters with the slope. What about the midpoint formula? Abby?
E equals x1 plus x2 over 2, and then y1 plus y2 over 2.
And then for the equation, remember, you're going to start by finding, class, the slope, and then use either point to find the equation. So, when we found the distance, if we were to subtract the x's, class, we get 3 or negative 3, but let's just say 3, and you square it to get 9. When you subtract, careful here, the y's, you get either negative 9 or positive 9, but when you square that, you get 81, and 9 plus 81 is? So we end up with the square root of 90, but I'm not going to leave that as my answer because it can reduce. Anyone? 9 times 10, so 3 times the square root of 10 units would be our length of that line. Make sure we're not cutting off the ends here. For the slope, here's where the order matters. How do we want to set up our y subtraction here? Genesis?
7 minus -2.
All right, so since you started with the 7, you got to start with the 4 minus the 7 ends up giving us what?
9
Which divided away gives you
3 over 1.
but
Negative.
negative 3 over 1 for our slope. For the midpoint, here, changing gears, we're going to add and divide by 2. So when we add 7 and 4, class, we get 11. Divide that by 2. 11 halves or 5 1/2 or 5.5. Add the y's together, class, you get 5. Divide that in half. 5 halves or 2 1/2 or 2.5. And for the equation, we're going to take the slope of negative 3. We're going to take, which point, Kendall?
4, 7.
4, 7. I like avoiding the negatives there. And we're going to say that y equals mx plus b, class. We call this what? Slope intercept form. Again, this is the slope formula. You use it to find slope. This is slope intercept form. It's the way a line will look when we plug in the numbers. So we plug in the 7 for the y, the negative 3 for the m, the 4 for the x plus b. We end up getting a b value, class, of 19. And so my equation here should be y equals negative 3x plus 19. Those who made it to this extra assignment, how many had all 4 of those correct? All right, most of you, I realize, didn't have a chance to get there. Questions on what we did? Questions? All right, let me flip back and make sure I'm not forgetting anything important here. Oh, what do we call that shape that a quadratic function produces? Parabola. What do we call the lowest or the highest point of a parabola? The vertex. Oh, the group of all the values that you can plug into a function, domain, all the values you can get out of a function. If I were to say, what do we call all the x values? That's domain, because that's what you plug in. All the f of x values is your range, because that's what you get out of the function. They didn't have you practicing any function notation. I think we're good. Does anyone want to practice with function notation? We do have a couple minutes. You want to practice with function notation, for instance, f of x equals, x squared minus 3x plus 1. Go ahead and do this at your seats real quick. Find f of 4 at your seats. And f of 4. It is. I wasn't quite ready for the answer there. It is 5, right? 16 minus 12 plus 1 is 5. We could go with those. Function notation. Okay. The form for direct variation. Y equals kx. The form for inverse variation. xy equals k. Again, the book says y equals k over x. Yeah, technically, there's a multiple of a reciprocal for inverse. There's just a multiple of the IV for the direct. But practically speaking, this is the way we went with it. We worked with that yesterday quite a bit as well. I think parallel lines. Same slope, perpendicular lines. Negative reciprocal slopes. All right, I think that's just about everything. All right, if you need to go back and rewatch parts of this video, or if you didn't finish some of the assignments, maybe you say, for instance, you'll have a couple sections like this. We'll be given a couple points, find a bunch of stuff, and you're like, ooh, I want more practice for that. Go back and watch the video, but watch it where it's on the board, but I haven't gone over it yet. See if you can get it all before I put it up, and then check your answers. You could do that if you felt so determined. A test tomorrow in lesson 106. And that will wrap up sections 4.1 to 4.5. And we'll do a lot more with functions after the test starting next week. Have a wonderful rest of your day, and you will be dismissed when the bell rings.
Can we practice coming?